All right, so now that we've discussed converting those units of measure, let's talk about another unit of measure, which is converting pounds to kilograms. So there are 2.2 pounds in 1 kilogram. Now we can arrive at this number. If you have a cell phone, fine, you can use your calculator, but generally they're not going to have you do that in class. So let's find a quick little way to do it. All right, it's a two-step process. Step 1, take the number of pounds and divide it by 2. So if we have 150 pounds and we divide that number by 2, 2 times 7 is 14. We have 1 left over. We bring the 0 down and 2 goes into 10 5 times. So we know that we have 75 from step 1. Okay? Then step 2 is to take 10% of the sum of step 1 and subtract it. So we're going to subtract 10% of the sum of step 1 from the total of step 1. So 10%, we can do it one of two ways. We can either say times 0.1, 1 times 5 is 5, 1 times 7 is 7. There's one space here with a decimal point, so we put one space here and put the decimal point. And we know that 10% of 75 is 7.5. That's not a whole number, so whenever something is 0.5 or above, we can round it up to the next whole number. If it's 0.4 or below, we round it down to the number. So this is 7.5, so we can round that up to 8. So we're going to take the sum from step 1, 75, subtract the number that we arrived at from step 2, and we know that we're going to have to borrow 1 from 7, so 15 minus 8 is 7, and after borrowing 1 from that column, that leaves 6 left. So our 150-pound patient equals 67 kilograms. Okay, now again, it's going to be a two-step process. First, take your number of pounds, divide by 2. When you arrive at that number, find 10%. So actually, we could say step 2 is find 10% of the sum of step 1. And then step 3, that's what's great about computer programs, is we can always erase in place. Then step 3 is going to be subtract the 10% of the sum of step 1 from the total of step 1. All right, and that's converting pounds to kilograms. And then if someone said, I've got a patient that weighs 57 kilograms, and they want to know how many pounds that is, you're going to multiply it by 2.2, and I'll just do the math for those of you whose math is needing a little help. 2 times 7 is 14, carry the 1. 2 times 5 is 10, plus the 1 is 11. Then I have to put a 0 here to hold this place. 2 times 7 again is 14. I'm going to Add a second one. 2 times 5 is 10, plus this one that I just added, that's 11. I'm going to add my two numbers together. These two are 2. Bring the 1 down. There's one space behind the decimal point, so I do 1 space behind the decimal point here. And I know that 57 kilograms is 125.4 pounds. All right, so that's converting pounds to kilograms, kilograms to pounds. Okay, so now we're going to be going over the equation to arrive at the concentration of a drug mixed in a solute in a container. All right, so we know that our dry units of measure are either going to be micrograms, milligrams, or grams. All right, and whenever we get a drug that's mixed or that comes in a package in the unit as big as a gram, once we mix that into a bag of fluid, to be able to administer fractions of this gram, we're going to measure it by measuring the number of milligrams that we're giving to our patient, because we can't administer the number of grams to our patient once we've mixed it in to something. We can, but it's going to be a fraction of a gram, and it's difficult to keep track of fractions. So we convert that number to milligrams. So we're going to say that we're giving the drug in milligrams to equal however many grams, the fraction of it. All right, so again, the concentration equation, this is going to be our dry units of measure. Okay, and that's going to be dissolved in a wet medium, right? And it's usually going to be some form of water. So it's going to be dissolved in a wet medium, which is usually something with water. And that is going to be measured in milliliters or liters. And typically it's going to be in milliliters. So since the dry is dissolved in the wet, we write it as a fraction, dry divided by the wet. This is how I think about it. That equals the concentration of a drug. And again, my way of remembering the simple formula for drug concentration is dry divided by wet, and I think to myself, dishwasher, because that's how houses are listed. If they have a dishwasher, they'll often put a D/W, and dishwashers need concentrate to wash the dishes. Dishwasher concentrate is what we put in the dishwasher to wash our dishes, right? So that's how I remember this formula for concentration. So how do I apply it? All right, so if I have a drug and it comes in a multi-use vial, and I know that my vial has 10 milliliters of fluid in it. That's the wet part. And then when the drug was made, they added 10 milligrams. Now let's say 5 milligrams worth of dry drug that they added it to the 10 milliliters of wet. So if I wanted to find out how many milligrams were in every single milliliter of fluid in here, then I would take my dry dose, which is my 5 milligrams, and then I would divide it by my wet concentration, which is 10 milliliters. And 5 is a whole number, right? So if we take this 5 and divide it by 10, we can see that 10 won't go into 5. So we're going to bring the decimal directly above it because we know that 10 will go into 50. So 10 goes into 55 times. All right, and then there's a 0 left over, and if we add a 0 to that number, it doesn't make the number larger or smaller. So there's 0.5, and we're always going to write a 0 in front of a point something, because if this gets written out and we miss that decimal point, we could accidentally administer 5 milligrams. So we know that there is 0.5 milligrams of this drug for every 1 milliliter of fluid. All right, so again, the dry dose divided by the wet volume equals the concentration so it'll be the number of milligrams or fractions thereof in the number of milliliters that it's dissolved in.